Hey everybody. So one of the things that people like about Funnelcast is that we show you an estimated probability distribution of where your sales may fall for a forecasted period. Now it looks something like this, and you can see the estimated relative probabilities of various sales outcomes. Today we're going to show you how you can estimate the probability distribution of the outcomes for your open pipeline using Monte Carlo simulations, the same technique we use in Funnelcast. And this is something you can reproduce easily in a spreadsheet, and we're going to show you how to do that. But first, let's focus on what a probability distribution shows you. Let's simplify this. We'll start with a pipeline that has just two opportunities. Each one has a known transaction value and an estimated probability, as shown here. Now, with only two opportunities, there are four possible outcomes. We can compute those outcomes directly and arrive at a probability distribution that looks like this, where each dot is one possible outcome, and the height shows the probability of each outcome. This is a probability distribution for the possible outcomes in that funnel. Technically, this is a discrete probability distribution. That is, there are discrete values that the outcome can take on. There are no chances of any other values. And to be precise, this is an estimated discrete probability distribution because the probabilities are estimated. So let's double the number of opportunities and see what happens. And we'll jigger with the probabilities and values a little bit. You'll see why in just a moment. So with 4 deals, there are now 16 possible outcomes. Here they are charted, and you can see why we jiggered those probabilities and values, so that the dots didn't all sit on top of each other, and now you can actually count how many dots there are in each range. So let's double again the number of opportunities. With 8 deals, there are now 256 possible outcomes, and it's getting harder to see what's going on. So one way to simplify this is just to count the number of dots within comparable sized outcome ranges, and then plot the number of dots in each range, like this. And we really don't need to see all the dots. So if we throw all those away, you get a histogram of possible outcomes. It looks like this. Now, what if we had a more realistic number of opportunities in our funnel? Let's say we had 50 opportunities. Well, with 50 opportunities, we have 2 to the 50th power possible outcomes. That's going to really tax your computer and your head to plot all those. We can't possibly compute them all, but we can hope to estimate it by simulating, and that's what we're going to show you how to do next. Okay, so here's a pipeline with 59 opportunities in it. Each one has a probability and an amount associated with it. The probabilities in this case come from Funnelcast, so they're pretty precise, and of course that's just the output of the model. Your probabilities can come from anywhere. They can come from what you manually compute, or they can come from a model of your own, or they can come from a third party's model. But if you just have a list of probabilities and amounts, you can create a Monte Carlo simulation. The whole idea behind Monte Carlo simulation is we can't possibly know all the combinations that could result, but we can simulate enough of them to get an approximation of what will happen. And that's what we're going to show you how to do here. So if you organize your data in this list format just like this, the first thing we want to do is generate a random number that we can compare to this probability. And if the random number, if between 0 and 1, if it's less than that probability, then we want to make the decision to say that that is a successful win of that deal. If it's greater than that figure, then it's not going to be a win. So let's do that. We use the random number function in Excel. If you do that, you'll see that this produces this 92% there. Let me do that again. If you hit F9, it'll recompute each time it's showing you, and you see you have a different random number. We want to make the comparison, is that less than that figure there? And if it is, then it's, in that case, it's a 1 deal. And if I recompute this enough times, it will eventually come up with a false. Okay, so now what we want to do is when you win it, we want to take this and we want to multiply it by the amount. And I'm going to do 2 things here to make this more useful. Let's column lock the amount and the probability. You'll see why we do that in just a moment, and we'll change this to a decimal. All right, so we can replicate that down. We'll go down to the bottom of the list and then copy down. And now I have, for every opportunity, independently simulated the outcome of the quarter or the forecast period. And we can add them all up top here. Let's do that. And we have the simulated outcome for that quarter. Now, you want to repeat that over and over again. So what you should do here is just copy that formula. Remember, we column locked the formula, so it should be copied to the right further. And we'll go all the way to the right, copy right, and there you go. We have it done. And now we have 16,000 simulations of the quarter. That's a lot of simulations, probably more than we need. But all we have to do now is select the top row, which is summarizing each quarter, and insert a chart. In this case, let's insert a histogram there. And there you have it. So there is a histogram showing the possible outcomes for the quarter as simulated by this Excel Monte Carlo simulation. And this technique can be expanded, the number of columns. If you just have more deals, just expand it down. And if it gets slow, you probably don't need 16,000 simulations. Typically 1,000 to 2,000 will get you a close enough approximation that will get the job done. So have fun with Monte Carlo simulation. And we'll look forward to seeing you in the next video. Bye for now.